The beginning of the Unit 3 notes will review ionic naming and formula writing, as well as covalent naming and formula writing. We'll review a little bit with naming acids, but not a ton. So these, again, are the notes packets from Unit 3, and it's just a review for naming and formula writing. While you're working on these notes, you will also want your yellow periodic table packet. And on page 3 is the periodic table of ions, which has the charges of your positive and negative ions. So that would be super helpful with naming ionic substances. So if you remember from long ago, trimester 1, ionic substances are made up of a metal and a nonmetal from the periodic table. So this is going to be a very rough drawing, but here is the periodic table. If you remember, the right-hand side has like a little zigzag line that goes down. And so everything to the left of the zigzag line is a metal, and then everything to the right is a nonmetal. So if you have a substance where you have one of the chemicals comes from the left-hand side and another one comes from the right-hand side of the periodic table, that would be an ionic substance. So with ionic naming and formula writing, you have to use the charges, the positive and negative charges, to write the formula. For the name, you would want to use your periodic table of ions to come up with the name. So we'll go through the examples at the bottom so you can add them into your notes. So one thing that I will note for the names, in general, if the name ends in "ide," so I'm going to put this over here. If name ends in "ide," generally that means it's a regular element from the periodic table. So it's a regular element on the periodic table. If the name ends in "ate" or "ite," so "ate" or "ite," that means that it contains a polyatomic ion. And so polyatomic ions are the ions that are in the box above the periodic table on page 3 of your yellow packet that we have from class. So that just kind of is a general guideline of where to look for those. There are, of course, a few exceptions. These two, for example, both end in "ide," but those are polyatomic ions. So those are the only two exceptions that you would really need to recognize or remember to look for in the polyatomic ion chart. Okay, so if we look at the first one, lithium cyanide, when you're writing the formula, we have to balance out the positive and the negative charges. So lithium is +1, cyanide is -1. So those charges are already equal and opposite, which means for the formula, you would need one lithium and one cyanide ion. So it'd just be LiCN. For the next example, calcium hydroxide, calcium is +2, hydroxide is -1. So these are not equal. So if you look at the charges, we would need 2 hydroxides to balance out our 1 calcium. So when you need more than one polyatomic ion, you have to use parentheses. So we would have Ca, parentheses, OH2, and the 2 would mean that we would need 2 of that entire hydroxide group. All right, we'll skip down to the next one, iron 2 nitrate. So iron 2, this Roman numeral means that iron has a +2 charge. So remember, the Roman numeral states the charge of that metal. And then nitrate is going to be a polyatomic ion, and that has a -1 charge. So we know we're going to need 2 nitrates. So iron is Fe, nitrate is a polyatomic ion, and since we need more than one, we have to use parentheses. So it would be FeNO3 2. The last one, potassium nitrite. Potassium is +1, Nitrite is NO2 and it has a -1 charge. So we would just need 1 potassium and 1 nitrite. So when you're writing the formulas, you do have to balance the positive and the negative charges. All right, now let's skip over to some of the naming practice. So the first one that you have to name is CuOH2. You know, it's kind of hard to see. This is CuOH2. Copper has more than 1 charge. So in the name, copper is going to need a Roman numeral in parentheses. So I'm going to leave it just like this, and then we'll go back to figure out what the Roman numeral should be. OH is hydroxide, and that is a polyatomic ion. So from this formula, we have 1 copper and we have 2 hydroxides. Each hydroxide is -1, which means your total negative charges would add up to -2, which means copper has to be +2 because it has to balance out the positive and negative charges. So the Roman numeral, remember, represents the charge of the metal. So it would be copper 2 hydroxide. And the very last one at the bottom, Li is lithium. And so remember, anytime you are naming compounds, you will only ever have 2 words. You'll have a word for the positive ion and a word for the negative ion. So then ClO, you would look on your periodic table of ions. ClO is in the middle column, and it is hypochlorite. So this would be lithium hypochlorite. So that's a review on ionic compounds. Covalent and molecular are made up of 2 nonmetals. So this is only 2 nonmetals. If you have more than 2 elements in the compound, they cannot be molecular or covalent. Molecular and covalent use prefixes in the name because they do not have a positive and negative charge. So the first one is CO2. So when you name a covalent compound, the first element, the name stays the same. You do not need a prefix if there's only one of that first element. The second element always gets a prefix. So 2 is di, and the name always ends in "ide." So the second element always gets a prefix and always ends in "ide." So we'll skip down to the next formula, O2F2. So the first element, the name stays the same, but we have more than one, so we're going to have dioxygen. Second element always gets a prefix and always ends in "ide." So it would be dioxygen difluoride. The third example is SO3. So again, first element, we do not need a prefix because there's only one. The name stays the same, so it'd be sulfur. Second element always gets a prefix, always ends in "ide." All right, so then when you're going from the name to the formula, you just have to look at the prefixes, and that's the subscript that you add. So dinitrogen means 2 nitrogens. Pentaoxide means 5 oxygens, so it'd be N2O5. The next one, chlorine, does not have a prefix, so it's just Cl, and then trifluoride would be 3 fluorides. And last but not least, carbon would only be 1 because it does not have a prefix. Tetra means 4, so it would be CCl4. On page 3, the only thing we mentioned about acids, so this is the top part with naming acids, is that acids start with hydrogen. So if you have a compound that starts with a hydrogen, right now you can assume that it's an acid. However, some groups got the naming rules and some didn't as far as trimester 1.1 and 1.2. So we are not going to worry about naming acids. If you have questions and want to know specifically, I can answer those. But in general, the formula for the acid would always be provided in your example. So we don't have to worry about naming acids. So hopefully that helps. As always, let me know what questions you have.